So in this tutorial, I'm going to show how to actually create an inverter from scratch. For that purpose, I'm actually going to create a new project called layout 2. And there it is. I'm going to select it and I'm going to edit layout. It's obviously empty since I haven't created anything. Again, I'm going to set the grid to, I'm going to start with 1 micron. It's sort of a convenient number. And the first thing I'm going to do is I'm actually going to draw the devices that I'm interested in. So the first device that I need for my inverter is an NMOS. And I'm going to bring up the device parameter box. I can set the width of the device, its length, a number of parameters that you would normally set in schematic. So it's an NMOS. It's actually, I'm going to use a 5 by 0.5 micron device with 2 fingers. So for a total of 10 micron wide and 0.5 micron long. A couple more things. Actually, we can play with it so you can see what happens. I'm going to create, first of all, I'm going to create a device. So this is my very first version of it. So by default, all MOS devices are fully guarded, and this will prevent all kinds of electrical problem later. We do not let people change those basic devices. They're parameterized cells, and the only way you're allowed to change them is through these boxes over here. If I were to use an m equal 2, this would actually add 2 separate blocks. Let me just show you very quickly, and you can see that we have 2 boxes inside the guard ring as opposed to 1. For the purpose of doing the inverter, I only need a single one. And I'm going to apply it. There we go. So single device over here. Bringing back the parameter box. So some of the things you can see, this particular device merges the drain of the device with source, drain, source in this particular example. And it has gate contacts both on top and on bottom. Now, for purpose of making an inverter, my PMOS devices is going to be on top, so I want my gate contact on top. I really don't need them at the bottom. They're not useful. I'm going to remove them. And for wiring purpose, it's actually oftentimes useful to shrink those contacts a little bit. They're a little big compared to what I want them to be. I'm going to use a gate coverage on the contact only to maybe 70%. And you can see that the gate contact is now thinner. I'm actually probably going to go a little smaller to 60%. The devices are perfectly symmetrical. The advantage now is I can actually put a piece of metal over here in between the gate and the drain and source of the device without shorting them, which is obviously important. So this device, this is good. I'm going to now do a PMOS device over here on top. Oops, where's my box over here? Parameters. So I'm going to use a 2x ratio between the NMOS and the PMOS. It's very standard. So I'm going to use a 10 micron by 0.5 micron device with 2 fingers. I'm only going to use maybe 80% ratio, and the device, well, let's create it first and take a look at it. I think that's probably the right thing to do. So it's perfectly aligned right now with my bottom device over here. My contacts are 80%. I might make them a little smaller, maybe 70%, just to have enough space to route a piece of metal. My top metal is going to be over here. I don't need to have gate contact on top on this particular device, so I'm going to remove the top gate contact. There we go, and now I have contact on top and bottom, and I'm going to close it. So notice I have no DRCs. These devices are correct by construction. Now, granted, this is not the tightest layout right now. I can probably select this cell. So I'm going to select my cell. Control I to select this. Let's select one on the PMOS device. Control I repetitively will select various level of cells that are available here. And using my arrows, I'm going to move it down, and I move it down by 1 micron. Clearly, there's no DRC. If I move it down, now I'm having some overlap issues between the two. Let me zoom in a little bit so we can see. You can see it's way too close. I'm going to shrink my grid to 0.1 micron just to get a little more accuracy, and I can move it until my DRC goes away. And DRC just count just 1 to 0. These devices can be this close to each other without any problem. Very convenient. So let me go to the bottom over here. I'm going to go to a slightly larger grid, maybe 0.5 micron. I'm going to draw my my ground basically. So the bottom is going to be ground. I'm going to do, it's 0.5 micron, so it's going to be, I'm going to do a 2 micron tall metal over here. There we go. And I need to connect that ground to my substrate and also my the sources of the device, which I'm going to pick on the other side. So you can see how being on the grid, I'm slightly off. I'm going to go again to finer grid, 0.1 micron. There we go. And using my box, I can do left corner and then right corner using the right button. And I can paint M1. So I can go over some metal 1 and middle click over here and get some M1. I'm going to do this several times. One here, one here. This is going to be my drain. This is this one here, middle button. I can also paint metal 1, by the way, by hitting just the number 1. 1 will paint metal 1. An easy mnemonic to do that. Okay, so I have this area over here. Has my metal 1. I want my gates to be connected together, so I'm going to zoom into the gate and I'm going to connect them together. So these two obviously joined. I'm going to, same thing, I'm going to connect these guys together. And now my 4 gates are all joined together. This is the input, and just for good measure, I'm going to do my input guy over here. And voila. That's easy. I can actually place a label, so I'm going to put the box around the area where I want my label. And using, oops, where is it? Cell, oops, where is it? My text over here. Edit text. I'm going to place a text label over this one called in. 1 micron high, might be a little big. I'm going to do it 0.5 micron maybe. It's going to be centered. No rotations attached to the default layer, which is going to be level 1. I'm going to apply it. And there we go. I have an in label on this point over here. And if I select the in, you can see it's connected to my gates quite nicely. On the top side, I'm going to do the same thing. So I want to have a VDD that's exactly the same height. I'm going to do S to select the piece of metal 1 over here, and I'm going to copy it over here using C. And there we go. My metal 1 just got copied, so it's exactly the same height. I'm going to, oops, abort, the wrong button. Using the arrows, I'm going to move it around a little bit until it's nice and centered, maybe exactly over here. Why not? It's not a bad area. And again, using the box, I'm going to place my box over here and hit 1, 1, 1, and 1. And now I've connected all my all my sources from the PMOS, including the ring, to my VDD. And this area here is now going to be VDD. I'm actually going to put a text label over it again. Edit text. This is, oops. This is a little bigger. I'm going to make a size of 1 micron. I have a little more space. It's going to be VDD. Apply. There we go. Okay, so this is my VDD label on this guy over here. So I've connected the VDDs. I connected the ground. Actually, I didn't label the ground over here. Let me do that. Put a select box. Edit text. And this is GND. Apply. And I have GND. Okay, ground and VDD were connected. The only thing I have left to do is now connect the drains together and make it the output. So I'm going to put a box area just to get the metal out. And I'm going to switch mode. I'm going to go to the wire mode on this one. I'm going to middle button, oops, there we go, wiring mode. I'm going to select, no, until, okay, so if you click multiple times, what's going to happen is you may not necessarily get the top layers. So what happened the first time I clicked over here, I got something else. So if I click here, it's going to select the NOL for some reason, which is not what I want. I'm going to right click to cancel, do it again. It's actually selecting the PDF, which is not what I want. Right click to cancel, middle click, and now I have the metal one. So it may take a few click and cancel using the right button to get to where you want, but I'm going to go this way and move it around. There we go. I'm going to go around, and then I'm going to do the same thing over here, and now connect to the output over here. And so if I select this particular piece of metal 1, and these are my outputs. I just run into a little problem over here, which is this particular device, I'm actually getting a number of DRC. And you can see here, there's some white area over here. And if I select and hit Y, it's going to tell me that my middle spacing is too close. It should be at least 0.45 micron. And indeed, here I'm on 0.1 micron gate, 1, 2, 3, 4. It's 0.4 micron. It's too short. Same thing over here. So one of two things, I can probably shrink my metal. So I can select an area where I have metal. If I hit Shift 1, which is the exclamation point, I will actually erase some metal. And you can see my DRC error went away. I can probably do that over here as well and erase some more metal. And I have slightly thinner metal, but my DRCs are away. Now, if I wanted to put a little more metal on this guy, there's a way of doing it. I can shrink my contacts over here. So I can Control I to select the NMOS. Control P would bring the parameter window. This guy was at 60%. I could probably put 55. apply. My contact's a little shorter, which means now I can probably go back to a slightly thicker metal without causing any errors. And sure enough, that is acceptable this time around. If you need to move metals and other things around, so let me hit S again to select the piece of metal I'm interested in. I'm going to hit S, repetitively until I hit the one I want. There we go. That's this one over here. And if I move the arrows, what's going to happen is just move that piece of metal without keeping connectivity, which is not good because now it's creating errors and moving up and down. If I hit Shift with the arrows, it actually keeps the connectivity. So now you can see my connectivity keeps moving, it keeps staying with me. But you can also see that as I move up and down, the errors are showing up in DRC, which is not what I want. So I can move things around until I do not have any DRCs. Very convenient. Last but not least, I want to label my output over here, which is going to be this guy. And again, edit text. This is going to be called out. Can be lowercase, can be uppercase. It really depends on what your preferences are. There's no magic rules. And well, now this node here is called out. And if I select it, oops, there we go. These are my two transistor drains, which are connected to the output. Always make sure to save. So it's a good idea. And right, and right, and right. Okay, it's written everything in there. So this is how you create a cell using the basic NMOS and PMOS devices. Thank you.